Okay. Now exercise. Okay. So now we want to find the domain of definition of this function. Part A. We know that this function is a rational function. It is defined when the denominator is different from 0. So we say x minus 1 is x minus 1 different from 0. This means x is different from 1. This makes x belongs to minus infinity 1 union 1 to plus infinity. It's minus infinity 1 union plus infinity. Now calculate the limits. We calculate the limits at the open boundaries of the domain of definition. We have limit as x tends to plus infinity. We have also limit as x tends to minus infinity. These limits are simple. In fact, if you replace infinity directly, you can take common denominator first of all here if you want, and then take the highest exponent. Or simply you can replace, you get plus infinity plus 1 minus number over infinity, which you know number over infinity is 0. So what do we get finally? Infinity plus 1 minus 0. The answer is infinity. The same here also. Minus infinity plus 1 minus 1 over minus infinity. This one is number over infinity is 0. 1 minus 0 is 1. Minus infinity plus 1 is minus infinity. What about the limits at the other boundary? 1 to the left and 1 to the right. Okay, let's replace 1. What do we get in both cases? 1 plus 1, 2 minus 1 over 0 minus. And here 2 minus 1 over 0 plus. We know number here over 0 minus. 1 over 0 minus, it's minus infinity. Minus infinity. And plus 2, we get minus infinity. And here number over 0 plus, it is plus infinity. Multiplied by minus, we get minus infinity. Sorry, here 1 over 0 minus is minus infinity. Multiplied by minus, we get plus infinity. These are the answers. Now, we want to find f prime of x and set up the table of variations of f. Let's go. This is f of x. So we have two methods to find the derivative here, or حتى limits, or whatever. Either leave it like this or take a common denominator. If you want to take a common denominator, the function becomes like this. We put this over 1 here, x plus 1 over 1, and then we multiply by the second denominator for تحت. What do we get? We multiply this by x minus 1, and here by x minus 1, all of it. And then what do we get? We get like this. X plus 1 into x minus 1, we get x squared minus 1 in the second fraction. That is finally, it becomes x squared minus 2 over x minus 1. كان فينا نعمل هذا الشيء كمان. We can do this to calculate limits. يعني اللي بعض منكم ممكن يكون عانى بالlimits بالسؤال اللي قبل. فينا نعمل الليميتس هون according to this method. Look, إذا رجعنا نعمل the same limits. Limit at plus infinity. We can take the limit as plus infinity, the highest exponent, x squared over x. Then simplify by x. We get limit as x tends to plus infinity of x over 1, which is x. Replace infinity, we get plus infinity. If you are at minus infinity, we'll get minus infinity. And if you are getting limit as x tends to 1 minus, for example, replace 1 in this, we get 1 minus 2 over 1 minus 1, 0 minus. number over 0 minus infinity multiplied by minus, it's plus infinity. ونفس اللي عملناه هون من شوي. Okay. But now we want to calculate the derivative. We can do this common denominator and find the derivative, or we can find the derivative directly. Let's say for this one, f prime of x is equal to, what's the derivative of x? It's 1. Derivative of 1 is 0. Minus, this is of the form k over u. This is of the form k over u. So this is k constant, and this is u. And the derivative of k over u is minus k u prime over u square. So what do we get in this case? Let's see. 1 plus 0 is 1. Minus multiplied by minus is plus. K is 1. U prime, which is the derivative of this, is also 1. So we get 1. And down we get u squared. This is u squared. It's x minus 1 squared. This is the answer. Also فينا نظبط الانسر بعد شوي. إذا بدنا ناخد common denominator, we get x minus 1 squared plus 1 over x minus 1 squared. وفينا نعمل expand in the numerator to get finally x squared minus 2x plus 1 plus 1, this is plus 2 over x minus 1 squared. This is the final answer. في عنا طريقة تانية كأننا نعملها هونيك. Yes. Let's see. نقول له f prime of x هون is equal to u prime v, لأنه this is a fraction, minus v prime u over v square. So it's equal to u prime, it's the derivative of the numerator, it's 2x, times the denominator, complete, full denominator. Then minus derivative of the denominator, which is 1, multiplied by the full numerator, which is x squared minus 2 over v squared. Now let's expand in the numerator. We get 2x squared minus 2x minus x squared plus 2 over v squared. Simplifying 2x squared minus x squared, we get x squared minus 2x plus 2 over v squared, which is x minus 1 squared. If you look at this answer, it is the same as the first method. So this is the derivative. Now, after finding the derivative, we are asked to set up the table of variations. Pay attention how we are going to set up the table of variations. We have, in fact, x squared minus 2x plus 2. This is the derivative. X squared minus 2x plus 2 divided. There's no need to expand the denominator. Because as we said before, the denominator بما انه square هو positive. Sorry. هو positive, strictly positive, لأنه 1 is excluded from the domain. هو positive over the domain of f. وحتى ما يفوش يكون equal to 0 لأنه أخذنا x minus 1 different from 0 in the domain of definition. So all what we have to do to study the sign of f prime is to study the sign of its numerator. What is the sign of this numerator? And you know, to study the sign of this quadratic equation, we have to find the roots using delta or using the calculator or whatever. In fact, the roots do not exist here. There are no roots, no real roots, because delta is negative, or using the calculator, we have no roots for f prime. So how to set up the table of variations? Put x here and f prime here. Now the first step in any table of variations is to put the domain of definition. يلي نحن we have found it before. It's minus infinity, plus infinity, and it's restricted or shaded, or we have a gap, or we have to exclude one from the domain like this. Like this, we are excluding one from the domain. Then after finding the domain of definition as a first step, or after putting the domain of definition in the table, we have to do what? To find the roots. To find the roots of the function. Because as we said several times, to study the sign of any function, we have first of all to find its roots. Okay, what are the roots here? And there are no real roots. لأنه حطيناها equal to 0 طلع ما في roots. طيب. Now the third step we have to put the sign. بما انه هون هلا كتار هون many would think that we have a root هون بيجي بيقول لي same او opposite same or whatever. No, here we don't have roots. And in the case we don't have roots, the sign is the same. Same sign. Same sign. Okay? So please wait to put the sign. According to the rule, if a quadratic equation has no real roots, then the sign is the same as A. A is positive. This is A. So here we have plus plus. Come on. Also, you can replace values here or here to know the sign. Finally, we add F. F is increasing here. F is increasing here. And the limit at plus infinity was calculated before. It's plus infinity. The limit at minus infinity was calculated. It was minus infinity. What about the limits as x tends to 1? At 1 minus, we get plus infinity, if you remember. And at 1 plus, we get minus infinity. So here we get plus infinity. Here we get minus infinity. And this is the end of this table of variations. Now, what about the last question, part D? Show that I12 is the center of symmetry. Let's show that the point I12 is the center of symmetry of the curve of F. Here, F of X is X plus 1 minus 1 over X minus 1. And the rule of the center of symmetry says F of 2A minus X plus F of X, it must be equal to 2B, where this is A and this is B. Upon replacing them, what do we get? F of 2 times A, which is 1, we get 2 minus X plus F of X. Let's verify that it is equal to 2 times B, which is 4. Now I know F of X. It's X plus 1 minus this. What about F of 2 minus X? This means to replace X by 2 minus X in each X found in F. That is, we get 2 minus X instead of X. Plus 1 ما فيها شيء minus 1 over كمان هون في X, we replace it by 2 minus X. And after simplifying this, what do we get? 2 plus 1, we can write 3 minus X minus 1 over 2 minus 1, it is 1 minus X. Here we have a plus X plus 1 minus 1 over X minus 1. Look now. This is 1 over 1 minus X, and this is 1 over X minus 1. They are opposite. They are opposite to each other. So their sum is equal to what? To 0. So this and this neglect each other. What do we get? Plus X and minus X also neglect each other. What do we get finally? 3 plus 1, which is equal to 4, verified. Now we move to the last question in the exercise or in the sheet. I have this function. First part, we have to calculate f of minus 1 equal how much? X is equal to minus 1. This means that X is less than 0. So we have to use the first section of the function to replace in it -1. What do we get? -1 plus 1, 0 over -2, which is equal to 0. Now, what about calculating f of 1? X equals to 1, it's positive. So we use the second expression for calculating f of 1, this one. Replace 1, we get f of -1 was 0, and f of 1 is equal to what? To 0 also. Now, we are asked to study the continuity of f at x equal to 1. How to show that the function is continuous at a certain value a? We have to calculate the limit as x tends to a plus, and the limit of f as x tends to a minus, which must be equal to f of a. Okay. Now, at x equal to 1, so limit as x tends to 1 plus 1 plus is more than 1. So we use the second expression. Okay, هون في عندنا مشكلة يا جماعة. Please, sorry, I'm so sorry. We have to correct the question. هو مش غلط يعني, بس it's better to study at the problem at 0. So we are asked to study at 0. Study the continuity of this function at x equal to 0. I repeat it again. Let's suppose that we have this function x plus 1 over x minus 1. X plus 1 over x minus 1. This in case x is negative, and x squared minus 1, this is in case x is positive or greater than or equal to 0. Now, what do we have to do? We have to find, first of all, the limit as x tends to a plus, which is 0 plus in this case. 0 plus, this means greater than 0. We use this expression, x squared minus 1, and we replace in it 0 plus. What do we get? 0 squared, 0 minus 1, the answer is -1. What about finding limit as x tends to 0 minus? 0 minus is a number which is less than 0. For this reason, we will use the first expression, x plus 1 over x minus 1, as x tends to 0 minus. This is 0 plus 1 over 0 minus 1. We get 1 over -1, which is equal to -1. And finally, we have to find f of 1. F of 0. That is, when x is equal to 0, also we replace here, we get 0 minus 1, which is equal to -1. As all the answers are equal, we say that f is continuous at this value, which is 0. So, as a limit at 0 plus of f equal limit of f at 0 minus equals to f of 0. This means f is continuous at x equal to 0.